So, I'm Senthil, I'm from Qubercomm, and I'm going to talk about can everyone hear me? Okay, in the back side? Okay. So, I'm going to talk about the home Wi-Fi systems, what's happening on the home segment, on the Wi-Fi, and what are the different challenges that that we are facing on the home Wi-Fi today, and what are the different things that are happening from a technology perspective on the Wi-Fi, home Wi-Fi. So, I'm trying to focus more on the home Wi-Fi systems, but some of these concepts are also applicable for enterprise. So, this is the agenda for the discussion today. As I talked about the home Wi-Fi requirements, what are the different requirements that people are having today, and what's happening on the Wi-Fi segment today. One is the requirement part, the other one is what is currently available, and I'll also give a little bit of introduction about the Wi-Fi repeaters and extenders, and give you an overview on the wireless distribution system and wireless mesh, and also talk about there are multiple APs that are coming into the home market today. So, what is the technical challenge behind employing multiple APs, and how the OEMs are basically dealing those challenges in the market today, and the different Wi-Fi mesh players that are currently available in the market, and we'll also talk about the issues the mesh players are currently going through, and also I just wanted to a little bit touch upon on the throughput metrics that we are able to get today with the different technologies that are available in the market, retail market today. And the final slide, I just quickly wanted to touch base on what Qubercomm is working on with respect to the wireless mesh products. Stop me if you have any questions. So, on the Wi-Fi requirements, as you see, better connectivity is the basic expectation from anybody who is using Wi-Fi, obviously, and it's becoming more and more today. And multiple access points, as I talked about, multiple access points has become very common in in the home segment. We'll also see why it has become a requirement, hardcore requirement in the market. And video and voice over wireless, obviously now more and more applications like WhatsApp and FaceTime and all these applications are coming up, and the bandwidth requirement also keep going up. So, the requirement of delivering a proper video and voice quality has become very important in the home market also today. It used to be a very basic requirement for the enterprise, but home also is very very much needed in the current home market today. And people prefer not to lay down cables, especially because if you want to have multiple APs at your home, you don't want to lay more cables. You want to live with the existing AP infrastructure or the cable infrastructure, and how to avoid running around cables, and and roaming and failover. Roaming has been a requirement again on the enterprise side, but even now with multiple APs coming into the home market, roaming is also picking up. And I think Srikanth briefly touched based on the various MBU and other programs that's going to help you on the roaming on the failover segment in the home market. And we talked about multiple access points, and I think the IoT is another big thing that's happening on the other side. I think slowly people aren't realizing that it's it's requiring a lot more Wi-Fi infrastructure that is heavily being used on the IoT side. In addition to Wi-Fi, there are other technologies also that are going to be needed in the home. So, that is also driving the factors of multi-APs that we will talk about in a minute. And Wi-Fi calling, obviously, it's one of the key features. And I think though in India it has not been very popularly used or not available today with the cellular vendors, in the US market people are using it, and Wi-Fi throughput and reliability is also a key factor. And mobile app and cloud managed Wi-Fi, now if you buy the multi-AP product from any vendor, you will likely to get a cloud access or a mobile access. So, that is also become a requirement now. So, without mobile application, people don't want to configure. Everything have to be easy for the users. So, that's where all the mobile application comes into picture. So, what's on the home market today? As you can see, there is a need for BLE, and BLE is also being very popular on the AP, and a lot of vendors you can see from the market players have already started integrating BLE and Zigbee, other IoT related radios, part of the Wi-Fi home infrastructure itself. And DOCSIS, another example in the US market. Without cable integration into your Wi-Fi router, people aren't going to buy it. And WDS has become very common today in the home market, wireless mesh, and PLC repeater, though it is not very popular in India. I think US they have product, and PLC is another way of extending the wireless range. And band steering and client steering, load balancing are all like a group of concepts. That's where the certification program that Srikanth talked about is going to help you. We'll talk about it in detail later, but I think the dual band is become the basic now. If you go back like 10 years ago, there used to be only single band, the throughputs were limited, but now any AP that you buy in the market today, it is minimum dual band, and tri-band, and multiple bands have started coming in. We'll see how the use cases have evolved and how people are leveraging all these multiple antennas technologies. And the Wi-Fi repeaters and extenders, this is a definition from Cable Labs, but I think with respect to the wireless distribution system, the naming is kind of a little bit confused. When I say distribution system and wireless distribution system, people think about single access point. That's actually not true. It's not a well defined terminology in my opinion, but a lot of people use the terminologies differently. But most commonly accepted terminologies is what we are going to talk about, which is repeaters and extenders. There are common technology names, and the Wi-Fi repeaters basically uses a single radio which will help you to amplify the Wi-Fi signals and get a better range and enhanced range for the home segment. So with a single radio, you will basically listen on to the other beacons from the AP, get the range extension provided to the other rooms in a larger home. The problem is obviously because it's a single radio, you can only do so much. The throughput is going to be decreased for the range extension. And the other Wi-Fi extender is another terminology that is popularly used. It uses two or more radios. For the BSS or AP operation, they might be using one radio dedicated, whereas the other radio is dedicated for the backhaul. So now the 3 radio is also coming in, and it uses one dedicated radio for the backhaul versus the 2.4 and 5G radio for the AP BSS. Okay, they're all very, very common in the market today. And WDS, as I talked about, it's a little bit misnamed in my opinion, but I think wireless distribution systems basically help you to connect multiple wireless access points at your home, and it uses 4 addressing. 4 addressing has been defined part of .11 spec in the early days, and though it has been just defined, people have not defined how it is to be used, and it is up to the vendor. It's been proprietary so far, and people have been using it differently. The only spec and the only point that the spec has highlighted is what is TA, what is RA, what is SA and DA, how to use it from a very high level. But unfortunately, the standard has not defined it very clearly. So people have started using it because the requirement have come even before the wireless mesh spec has been ratified. So people have been using it differently. That's one of the reasons why the technology has not been very much interoperable with other vendors. And enabled wireless bridging, obviously WDS, one of the major reasons why people have been using it on the home market is to extend the range and provide wireless bridging. We'll talk about what is wireless bridging in the next slide. So I'll wait for that. So implementation differs from vendor to vendor, which I just highlighted. And WDS, the wireless bridging and wireless repeating. The wireless bridging basically being used primarily to extend the wireless range from one place to other place within a home or within a bigger campus, but it does not offer any BSS operation. So basically there are multiple connected equipments with a Cat6 cable in one room, and you have multiple NAS servers and other equipments on another room, let's say, and you just want to extend the wireless range. People typically use the terminology called wireless bridging, where you keep one AP on the one room and the other room you keep another AP, just get wirelessly connected, but it doesn't really serve any wireless access from mobile phones or such. So I think I have a slide to talk about it. This is the typical wireless bridge that you normally see in the market. So as you can see, this is the wireless distribution system station, and you can see a WDS AP on the other side. There are laptops connected with wires. For the simple discussion, let's keep it complete, wired connections between these laptops to the WDS star. From there, the wireless link takes the wireless range extension to the other place. From there, multiple other laptops are connected using wire. So as you can see, some reason it's not coming up properly. Okay, fine. So now you can see this whenever a frame is sent by this laptop to the laptop in the other room or other segment, you can see the .3 802.3 frame that goes to the AP, and the AP bridges the .3 to the .11, and you can see all the different 4 addressing formats specified by the specifications are leveraged, and these frame will go to the other AP. From there it travels down to the wired terminal or wired laptop using a standard .3 format. So this is typical. If you look at this particular architecture, the topology, you don't see any wireless clients that is connected, right? So, but this is not what you see in the market today, but this is how it started. Wireless bridging was the primary reason behind the WDS, and people have started using it, and now it is a little bit advanced. So as you can see, the WDS AP will basically only serve this client, okay, and there are no more wireless clients that are connected to it. And WDS star, obviously they don't have any BSS AP operation. It just creates a single WAP, and that WAP primarily is used to connect to the range extender AP, the primary source AP. Okay, and going back to the slide, the other part of the discussion is about the wireless repeater. So repeater, in addition to the same wireless bridge that you talked about here, you're going to have wireless clients that are associated to both of the APs. One is the WDS AP and the other one is the WDS star. And the problem is, if you look at WDS, several companies have several methods. How do I get data from this side to the other side? One is I use WDS obviously with the 4 address frame format. The other people in the past, even like 7 years, 10 years ago, if you look at it, people have started shipping products, especially the early Linksys products. If you look at it, they have a WDS AP to AP model, and then they were using not 4 addresses frame format. They were using some kind of L3 NAT. For many of you who are using the networking products, it's very popular. They are using L3 NAT, and there are companies like Netgear. They've been Linksys. I think they were also using L2 level NAT. Okay, there are because the technologies that they are using to bridge the frames from one room to the other room, and it is completely even with their own models of different models of the same vendor AP, you see differences in the way how the data is basically bridged from one room to the other room, right? So that basically brought in the complexity of this technology is not being very interoperable, which is good for the OEMs, because when it is not interoperable, you have to buy everything from me. So I'm happy. I don't want to support something standard which is like a 802.11s, but we'll talk about 11s in detail. But these are the practical problems, and as you can see, the Linksys and other people have claimed that the WDS link, if you are AP WDS to AP WDS, you cannot basically use a key rotation and all the other concepts, which limits. In the early days, if you look at it, limits the usage of WPA and WPA2, which uses the key rotation as a key concept for providing better security. So many limitations were basically part of the technology. If you look at it, if you don't, many people claim that I support WPA and WPA2, but in reality they don't use WPA2, because unless you leverage the complete concept of the WPA2, the security is not going to be very good. So unfortunately, that is how people have been living so far, and we don't know. We just send data, receive the data on the other side, and then because it's being very proprietary, many times you don't understand except the 4 addressing format. What do they communicate between these AP and other APs, right? And sometimes they don't even use a standard frame format. They might use a proprietary frame format also, because both sides are their device, right? So you don't. If you look at if you run a sniffer and then see the frames, you wouldn't basically understand anything out of it, right? Yeah, and each hop, obviously, because the wireless is naturally hop duplex, each hop you are trying to get the data extend, you're going to lose the throughput by 50%. I mean, nothing can be done about it. So this is true for any technology, wireless technology, that you use to extend the data from one place to other place. So that is something very basic. So if you look at it here, the difference between the wireless bridge and the wireless repeater, the wireless bridge does not have any AP BSS. In this case, there is a AP BSS. you can technically have AP bases on both WDS, both WDS ends, okay, so that you can provide wireless access to both sides. So wireless mesh is it's a proper IEEE spec, 802.11s. Many of you are aware of it. What is the advantage of wireless mesh over a wireless distribution system? We'll talk about it, but I think wireless mesh provides flexibility, obviously, and it is self-forming. You can basically bring in a new wireless mesh node and then easily associate to the existing wireless mesh network. Similarly, if there are nodes that are going to go down, you can easily handle the healing part of it also. Automatically it is healed because one path is going down, because the spec also defines about the shortest path first, and there are routing algorithms within the mesh. It will help you to get from one destination to another destination very easily, and it is all properly validated. In fact, when they have written spec, I'm sure they would have looked at the existing range extension and wireless distribution stuff. So they would have properly looked at all these aspects, and then they have come up with a lot of good concepts in the wireless mesh, and it's actually picking up. I have some data to kind of talk about it. So based on that, you can feel that yes, wireless mesh is also picking up. If you look at like 3-4 years ago, if you had asked me, I would also say a wireless mesh is not going to be popular. I was also thinking, why the hell should I use wireless mesh, right? But now I see a lot more use cases that are actually leveraging, especially with the advent of IoT being the big market in the worldwide. I think that is also leveraging some part of it, right? And another thing, Wi-Fi mesh is also suitable for large campuses and stadiums, unlike WDS. Here, typically people use it in a very large campus. Those kind of implementations already exist in the in the market today. And I think the picture part, I think you can see buildings within a city Wi-Fi mesh or a large campus Wi-Fi mesh. People have multiple antennas on the different buildings, and then they talk to each other. You have in addition to the mesh, once again, so in addition to the mesh link that you see here between MP1 and MP2 is a mesh point, and you also have a BSS operation here, which you can basically connect to the locally available BSS that is out of MP4. Similarly, MP1 can serve. So it is up to the configuration that you basically have part of the Wi-Fi mesh nodes to also be part of AP BSS. Okay. And I think in the interest of time, I'll because we need to talk more on the data front, I'll skip the mesh which is basically available in the specification. We can come back if we have a little bit time in the end. So multiple APs, what are the typical challenges that we have? So obviously there are multiple band, right? Multiple antennas. So how many bands should I get it to the extender? For example, when people are supporting multiple dual band, should I get the dual band also extended to the other rooms, or should I give only the single band extended to the other rooms, right? If you look at typically OEM vendors are actually advising, if you buy a TP-Link or any standard retail router, they will tell you if you are doing a wireless extension using WDS, you enable only one radio and then get it extended to the other radio, right? So technically speaking, both radios you can be able to extend it to the other areas. But there are technical challenges about like how do you basically avoid the loop when you extend both 2.4 and 5G. How are you going to avoid all the loop aspects, and how do you basically manage the backhaul also, right? So and smooth failover, that is another key aspects of it. So when one of the links are going down, how do you basically handle those link failures very easily, right? So they are all completely proprietary. Every vendor does it differently. So there is no unique or standard method that is 100% foolproof today, right? So every method has one or other disadvantages today, but it has been running so far well because predominantly people are using only a single band range extension compared to the multi-band range extensions today. Okay. So there are multiple players, and we also look at multiple issues related to the market. As you can see, all the players are having multiple AP products or mesh products or WDS based products in the market. You can see almost all top players are basically part of this list, and all of these vendors, OEM vendors, are basically giving either 2 radio or 3 radio solutions, right? And they also provide mesh or WDS. For some reason, some vendors go to mesh. For some reason, other vendors goes to mesh, and we'll try to understand why they are choosing and how they are choosing, right? And also cost is another factor, because the more and more antennas and more radios that I'm going to add it to the equipment, it's going to cost more, right? So what are the cost benefits? Should I really go for a three radio solutions, or am I okay with the two radio solutions, given that it's a simple home kind of a setup, right? And ease of setup, that's very important, because if you buy market products, I'm sure, especially for some of these even the top vendors product, it's very difficult for a non-Wi-Fi users to connect it very easily, because it's no more Wi-Fi today. See, many vendors, they are using other technologies like BLE, for example, and the mobile phone. They give you a mobile app. Without mobile app, you cannot do anything. And most often what happens is, if you buy any of these products from the US and get it down to India, in many of these iOS applications, they will not be available for India. The moment they find you out in being in use, using this APs in India, they don't allow you to configure, right? It's not very simple to configure, and some of the players have actually taken it very seriously. They provide a lot of other mechanisms to easily configure. For example, they give a little bit WPS kind of a switch button. Just press it, it gets auto synchronized, auto initialize, and it joins the mesh automatically. Whereas the other vendors, if you look at it, you have to get a mobile app to a node, you have to get the same mobile app to the other node. In some cases, they say, can you keep all these nodes together, only then I will allow you to configure. So there are a lot of challenges. So the ease of setup is a key point for being successful in the WDS and mesh market today, right? So I'm not going to talk about how each and every people are going doing it, but in general, for a non-Wi-Fi user to configure all these technologies are not going to be very easy. It's very difficult. And the throughput metrics, I'm not going to very details here, but the highlighted, you can see it offline. Highlight is basically between the WDS and the 11S, there is not much throughput difference. That's a key point that I wanted to highlight here, and you can see the data offline. But as you can see, out of the major players on the WDS and mesh market, you can see this. One second. You can see the technologies that are being leveraged today. You can see more and more. So if I had put down the same slide like 3 years ago, you would see only WDS in this column. But now you see more mesh players are coming in the market. Even the top player, for licensing and other reasons, I don't want to name them, but I think they're all top brands in the retail market that are selling today, and they're all using 11S today, right? That tells obviously all vendors are convinced that this 11S is going to pick up really fast, right? And also the throughput metrics on the mesh node. What you see in the previous slide is basically the root node, and you have a mesh node which is an extender node. So both nodes, if you look at it, the throughput is actually not degraded with respect to 11S. In fact, depending on the topology, 11S can give you a better throughput, compared to WDS, because in WDS you have to go through the root AP every time. In the WDS, unlike WDS, in the mesh case, you can directly reach out to the peer, so that has a lot of advantages, especially the topology. If you form the topology properly, I think you will gain a lot with the 11S, okay? And I think another key point I wanted to touch base on, there is no leverage for IoT as such, right, with respect to WDS. But IoT has, the mesh has a lot more potential for IoT, because a lot of IoT equipment, they cannot just come and implement WDS and expect them to work with existing Wi-Fi infrastructure at their home. But with respect to mesh, because it is being standardized, and if IoT devices start supporting mesh, I'm sure they'll see a lot of value add on top of mesh. They can form their own mesh. Tomorrow I will even argue that my smart AC and my smart fridge can become a wireless relay as compared to existing devices that I need to buy. Anyway, every devices are becoming Wi-Fi integrated, which is going to be soon, very soon. So why shouldn't I use my existing equipment that I'm having, a smart equipment can act me as a mesh range extender. I can save cost, right? One second, I think there is something. So WDS mesh, I think we briefly talked about it. I think I'll just keep it a little short and probably open up for answer sessions. Okay. I have listed is on the retail market. Okay, there are equipment on the enterprise grade market also that can be used for the large scale deployments. So the enterprise markets aren't using 11s today. It has been very popular in the home segment, but still, you know, it can be leveraged for the bigger segment also, because if you look at it, the from a technical perspective, both enterprise and retail were using the same WDS or equivalent, you know, methods for range extension. When it can be successful locally, I don't see any reason why it can actually be, you know, it can be a failure model in the enterprise market also. Right? Not on the enterprise market today, but I'm sure people are working on it. I know people are actually working on it. On time, yes. I think you know, it can, but it depends on the use case, right? So depending on what kind of you know, use case that you are looking at, mesh can help you, because the underlying technology is based on, again, it is going back to CSMA and CD and you know, basic Wi-Fi infrastructure.
No, but can mesh withstand the rigorous QoS for a voice transfer? Say in small cell today, it's a very big building. Carriers actually install the small cell on that building and provide your mobile access basically for voice and data. But voice, let us take voice as a key because the QoS is very high. In that case, if you are going to go with mesh for the long range enterprise, a campus kind of deployment, can mesh satisfy that voice requirement?
Yeah, definitely for a campus, I would say yes, there is no doubt. But for a bigger city kind of an implementation where it is not just Wi-Fi, because many of the city deployments, point to point, point to multi-point that are happening today, if you look at it, they are not using CSMA, right? I mean, they are using TDMA or something equivalent. So in those cases, the latency might be higher, in my opinion. So you cannot really use for all sort of applications. But if my intentions are not latency based, my intentions are just to extend the range from one place to another place, I can use it.
Thanks, Senthil. Please give him a hand. So, Senthil is also one of the key contributors to the mesh O11S code in the open source. So, feel free to talk to him if you are more interested in the 11S kind of code. Thanks, Senthil.
Thank you. Yeah.